Hi guys, we are the group 2 and we are assigned to report the ANOVA. So first, what is ANOVA? Analysis of variance, or ANOVA, is a collection of statistical models and their associated estimation procedures, such as the variation among and between groups, used to analyze the difference among group means in a sample. ANOVA have two types, which is the one-way and the two-way ANOVA. Let me discuss the one-way ANOVA. So first, we'll be having the table, which is here. So yung table natin is 1, 2, and 3. So pagpalagay natin ng sa gasoline station, meron tayong counter 1, 2, and 3. Ito yung top 1, top 2, top 3. Let's say meron nagpaga sa counter number 1. Yung una niyang customer is umabot siya ng 1 minute, and then sumunod is yung 2 minutes, and then yung last is 5. So ganun rin nangyayari sa second at sa third. Pero magkakaiba sila ng time. So may second, meron tayo 2 minutes, 4, and 2. While on the third, we'll be having the 2, 3, and 4. Ito na yung table natin. So the first step in ANOVA, one-way ANOVA, is we will be having the hypothesis, which is the null and alternative. For the null, we have the mu1, mu2, and mu3 are all equal. For the alternative hypothesis, we have at least one different among the means. Next is for the alpha, or the significance level. So alpha have important role in this ANOVA. Dito natin i-discuss yung chance na ma-reject yung hypothesis. So usually ang ginagamit dito is 90, 95, and 98. So ang ginamit natin for this is 95. Yung minus natin siya sa 100, which is 5%. So yung 5% tayo pag convert natin decimal is 0.05. So yun yung alpha level niya, or significance. We will be discussing the degrees of freedom. So how to get degrees of freedom? We have two, which is the degrees of freedom between and within. To get the freedoms between, we will be needing k minus 1. So take note of that because it's the solution or the formula. So k minus 1. So saan natin makukuha yung k? So yung k is yung kanina, we'll go back tayo dito, which is yung tatlong counter. So k is equals to 3. So 3 minus 1. So the degrees of freedom between is equals to 2. So degrees of freedom within naman, meron tayo dito formula na n minus k. So kanina, yung k, kung paano natin nakuha is ito, tatlong counter, which is tatlo nga sila. So 3. While yung n, para makuha natin siya, is bibilangin lang na natin ito lahat. Lahat nung nandito sa table. So 3 plus 3 plus 3 equals 9. So, n minus k or 9 minus 3 is equals to 6. So, yun yung degrees of freedom within. So, next natin, pagkatapos natin makuha degrees of freedom of between and degrees of freedom within, which is 2 and 6, is total natin siya by simply adding it. So, 6 plus 3 equals 8. And next step is, dito na natin, i-discuss yung F critical. So, paano natin ba makuha yung F critical? So, F critical, meron tayong kailangan na dalawa, which is yung degrees of freedom within and between. So, nakuha natin yung 2 and 6, which is the two key values. So, yung difference between is i-base natin siya sa numerator, and the difference within is 6, which is the denominator. So, kung titingnan niyo sa table, makakuha tayo ng 5.14. So, F critical natin is 5.14. Step 3, kuha natin yung mean ng bawat isa. So, mean 1, mean 2, and mean 3. Ipag-add natin lahat ng variables here. 1 plus 2 plus 5. Next is 2 plus 4 plus 2. Next naman is 2, 3, and 4. After nyan, paano ba natin makuha yung mean? Di ba yung summation muna nitong lahat over kung ilan siya? Like this one. 1 plus 2 plus 5 equals 8 over 3. Ito, ang kakalabasan niya is 2.67. Same with this, 2.67. And for the last is 3. So, ganun lang yun. Kinukuha lang natin lahat ng mean nila. Now, for the grand mean, kailangan natin ng grand total. I-add natin to 1 plus 2 plus 5, 2 plus 4 plus 2, 2 plus 3 plus 4, magiging 25. And then yung n is kung ilan siya. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, 25 divided by 9 is equals to 2.78. So, ito na yung grand total natin. Next, we have the summation of squares. So, summation of squares total. So, in order para makuha yun, mayroon tayong formula summation of each score minus the grand mean squared. So, gagawin natin is lahat ng score, diba? Of each score. 1 is 1, minus the grand mean, which is 2.78, plus 2 minus 2.78 squared, plus 5 minus the grand mean, which is 2.78 squared, plus so on siya. Summation of squares total is equals to 13.6. So, after po natin ang summation of squares in total, hahanapin naman natin yung within. Kailangan natin ng formula ng summation of x1 minus the mean of that condition plus the x2 minus the mean of that condition plus x3 minus the mean of that condition. So, x1, 1 minus 2.67 squared plus 2 minus 2.67 squared plus yung x3 is yung 5 minus 2.67 squared. So, if we sum all of this, we will get 13.34. So, here's the final result of the SS within. So, after natin makuha yung SS total, SS within, meron naman tayong SS between. Para makuha siya, pagmaminosin lang natin itong SS total and SS within, which is 13.6 minus 13.3. Magkakaroon tayo ng 0.13. For the next step, which is the step 4, we will be having the mean square between and the mean square within. Para makuha yon, kailangan natin ng SS between over degrees of freedom between. So, SS within over degrees of freedom within. So, sinubstitute natin siya, it will be equal to 0.12. Same with the other one, substitute lang natin. So, kapag divide natin siya, makakuha tayo na 2.22. So, next, this is the last step, which is a step 5. Finally, step 5, meron tayong formula F is equals to MS between over MS within. Isa-substitute natin yung MS between at MS within. So, kapag tinotal natin siya, is magiging 0.05. And next, if we will bring back the F critical, you guys remember that we get 5.14. So, F, which is 0.05, is less than 5.14 or the critical. So, in this case, we fail to reject the null hypothesis. And remember, our null hypothesis is mean 1 was equal to mean 2 was equal to mean 3. And since we are failed to reject that, we conclude that there is no significant difference between the three groups. And we're now moving on calculating the two-way ANOVA. So, to calculate the two-way ANOVA, we must first start with our sum of squares. So, sum of squares, we have 4, which is the sum of square first factor, sum of squares of the second factor, sum of squares of within, sum of squares of both factors, and the total of sum of squares total factor. So, take a look on the given table. We have that gender, score, and age group. So, in each gender, there is boy, girls, boy, girls, boy, girls. And for the age group, we have 3 different groups, which is the 10 years old, 11 years old, and 12 years old. And in the middle, you can see the scores of each. We have the 3 table, which is the boys, girls, and the mean table. We'll get the mean of each group, like the boys and the girls. So, as you will see, we have 3 columns here, which is the 10, 11, and 12 years old. If we get the mean, we can get that by adding this 3, 4 plus 6 plus 8, and the total of it is divided into 3, which is 6. For the boys, we get the 6, 7, and 10. So same with the girls, 7, 10, and 14. Then to get the average, add this 3 and divide it by 3, so you got the 7.7 and you'll get the 10.3. Then next, so to get the average, we simply add this 2 and divided it by 2. So 6 plus 7 is equals to 13 and divided by 2, you'll get the 6.5, same with the other column. So 7 plus 10 divided by 2, you'll get the 8.5. 10 plus 14 divided by 2, we have the 7.7. Then you'll get 9. So that's how you get the mean table. You can also call it as marginal mean. So after those many tables, it will serve as our basis for the next step. So for the next step, we will begin with the sum of squares, which is the first factor or the gender. So to get this, I get the data of boys, and here are the scores. And if you would total it and get the mean, you'll get 7.7. So after you get the boys mean, you'll just minus it to the grand mean, which we get from the mean table. And our grand mean is 9. And if we will minus 7.7 minus 9, we will get negative 1.3, and then we will square it. We will get the 1.8. And this one, 1.8 is the final answer. And then after we get this 1.8, we will be counting this one. So it is equal to 9. So it means 1.8 times 9. So we will get 16 for it. So for the girls, we have the same data but different scores. And if we total it and divide it by 9, the girls' mean, we will get this 10.3. And then again, same thing with the boys. We will minus it to the grand mean, which is 9. So in this case, we will get 1.3 but into positive form. And then square, so we'll get 1.8. So same thing with the boys, times 9. So if we sum it up, we will get 16.2. So for the sum of squares first factor, we will just add this 2. So if we add it, we will get 32. And that is for our first factor. And now for the sum of squares second factor, which is the age, we will be using the 6.5, 8.5, and the 12. And now for the sum of squares second factor, which is age, we will be having the formula of average total minus the grand total mean. And we'll get this negative 2.5, negative 0.5, 3, and then square it all. We'll get the 6.3, 0.25, 9, and to sum it all, we will be having 46.5. So for the girls, we have these scores, and then average total minus the grand mean, we will get the same exact answer as the boys. So in that way, we will be having 46.5, and then combine the boys and girls, we'll get the 93. So our sum of squares second factor, which is 8, is equal to 93. And for the third sum of squares, which is within or the error, we're going back to the other table, which is the boys table, and the scores of it, and then we'll get the age mean, which is 6, 7, and 10 from the table. So after you compare it, we'll just square the answer and we'll get 4.0, 0.0, 4.0, and so on. And if we will combine all of this, we will get the 28.0 for the boys. And next for the girls, same thing with the girls but different data scores. After you compare the girls score and age mean, you have to square it and you'll get this data. And if you will sum it up, you'll get the 40.0, and then if you combine this is the 40 and 28, you'll get 68, which is for sum of squares within. We will be moving on to the sum of squares total before the sum of squares of both factors. So to get the sum of squares total, we have here the table. We have the formula of score minus the grand mean. So our grand mean is 9, and we have our scores, which is for the boys and the girls. We'll just compare it to the grand mean, which is 9, and then we will just simply square it and we'll get this data. So after this data, we will be having 200, which is our sum of squares total. So after gathering all the data except for the both factors, so to get the both factors, we can simply algebra this. So SS total minus SS factor minus SS second factor and SS within. So we can have that 200 minus 32 minus 93 minus 68, and we will simply get 7, or the SS both factors. Let me sum it up. The sum of squares first factor is 32 plus sum of squares of the second factor, which is 93, plus sum of squares within, which is 68, plus sum of squares of both factors is 7 and 200. So that is all for the sum of squares.
Okay, so now we are done on how to calculate the two factors and get their mean, which is the boys and girls. Now, we are moving to the how to interpret the results of a two-way ANOVA. But next, we have to establish our hypothesis. So we have 3 hypotheses here. So our first hypothesis is gender will have no significant effect on student score. And the next is age will have no significant effect on student score. Next is gender and age interaction will have no significant effect on student score. Okay, so now we are done on how to establishing a hypothesis. Now we move on to the table to interpret the two-way ANOVA. First, we have to get the degree of freedom of sum of squares of the first factor, which is the gender. We have 2 gender here, which is boys and girls. Now we have to count the degrees of freedom of both factors. Now we have to count the 1 and 2. And we have the 2 and minus it by 1. We have the formula of n minus 1 and this equal to 1. And we have the value of degrees of freedom of 1 for the first factor. Now we have to get the factors of second factor, which is the age. So we have 3 categories of age and we have to count it for 1, 2, 3 and n minus 1. And we have the value of 3 as you remember, and it is equal to 2. Now we get the value of 2 and 1 for the first factor of gender, the second factor of age. And for the next is sum of squares within error. Now to get the value of degrees of freedom of sum of square within error, we have the 2 tables and the 2 factors that represents the boys and girls. Now we have different categories. We have the 10 years old, 11 years old, and 12 years old for boys, and 10 years old, 11 years old, and 12 years old for girls. Now we have to count the age per category to boys and girls. Now we have the 3 categories to boys. We have the age of 4, 6, and 8. As you remember for the last solving the degrees of freedom, we have to count the age. Now 1, 2, 3. Now we have the value of 3 minus 1 equals 2, and so on. Now for the girls is same process. So if we sum this result, we have the value of 12. That's why we get the result of degrees of freedom of sum of squares within. Okay, now we have to go back to the sum of squares of both factors. As you can see, we have the factors of 2. We have the age and gender. If we combine the age and gender, we will have the results of 2. But how? We have to multiply degrees of freedom of gender, which is the 1, and multiply it by the degrees of freedom of 2, and we have the result of 2, and we have the value of sum of squares of both factors. Okay, so now we have to get the mean square of both factors. But first, we have to divide the first factor of gender from 32 to 1. We get the value of 32. Now, to get the F ratio, we have to get the sum of squares within error, which is 68 divide 12. We get the value of 5.67. The 5.67 will be the main average or value to get the value of F ratio. So 5.67 divide 32, we have the value of 5.64. Okay, so for the result of first factor, we have the z-scores of 4.5, which is, as you can see, it is a skewed. We have the value of 4.5 from the ratio of 5.64, and we look at to the z-scores. Remember, we have distance of freedom denominator. We have the value of 1 and 12. These two are distance freedom of denominator. Now, as you can see, the 4.5 will reject the first null hypothesis, and our alternative hypothesis is gender does have significant effect on student score. Okay, now to get the mean square of the second factor, which is age, we have to divide again the 93 divide 2. We have the value of 46.50, and divide it to the value of sum of square within error, which is the 5.67. Now we have the value of 8.20. Now we have to get the z-scores of 8.20. After we get the z-scores of 8.20, now we have the value of 3.89, which is the score. Now as you can see, the hypothesis of sum of square of second factor, which is the age, is rejected. So it will be age has a significant effect on student score. Okay, now for our last process, we have to divide the value of mean square of 7 divide 2. For both factors, we have the value of 3.5, and divide again to 5.67, and we have the value of 0.62. Now, we have to get the F ratio and its z-scores from the z-table. After we get it, we have to interpret the relative frequency, if it is normal or not. Now, we have the result of 0.62, and as you can see, it is fail not to reject. So our third hypothesis is fail not to reject. The null hypothesis is still gender and age interaction will have no significant effect on student score. Okay, thank you.